Good morning. All right, everyone, so let's continue with our discussion on PEMDAS. Last class, we discussed the P in PEMDAS referred to parentheses, and we also learned that parentheses looks different, right? Like it could be an actual set of parentheses, it could be a set of brackets, it could be braces, it could be absolute value bars, it could be a radical. So anything that houses information is where you're going to want to focus your energies, at least at first. We also learned that you want to work from the innermost set of parentheses outwards, and we're going to see an interesting example coming up after we finish this discussion on the E, M, D, A, and S in PEMDAS. So let's take a look and see how it goes. So next in our order of operations, after we focus on what's inside a set of parentheses, meaning if there are operations that must be performed within a set of parentheses, you will do that first. Hi, Kevin. So after we simplify what's inside the set of parentheses, you then want to move into exponents. Now, I want you to be very careful when you think about applying exponents. So I'm going to show you two very different expressions with different values. So take a look at this first expression. So here's an example that I want you to consider. Take a look at this expression, negative 7 squared versus negative 7 squared. Weird, right? You're probably thinking, aren't those kind of the same thing? Well, actually, they're not. So what I want you to consider is the main difference, the physical difference. Your first example, there's no set of parentheses. Your second example, there is a set of parentheses. We know that when we take a base and we raise it to the second power, we take that same base and we multiply it by itself. So for instance, we have the negative 7 quantity raised to the second power. So technically, this can be rewritten as negative 7 times negative 7. We know that negative 7 times negative 7 is a positive 49. Now, interestingly enough, when we look at our first expression, this has to be different than our second. It looks different. So it should make sense that that there should be a difference in terms of the actual result. So what I want you to note here and what might help you all is that if you do not have a set of parentheses, that power actually applies to the numerical base. That negative is simply, it's almost like saying negative 1 times 7 squared. That's essentially what that expression says. So what may help is drawing a circle around the exponent and its respective base. So what that means is you're going to take that 7 squared, you're going to evaluate it, and then you're going to bring that negative down, just like we did when we evaluated the absolute value expressions from last class. Okay? So keep that in mind. When you have parentheses already included in your expression, and there are parentheses around that negative number, and then you're raising it to a power, consider how that impacts the sign. When you raise a negative quantity to an even power, it will become positive. But that should make sense. Think about the discussion we had. A negative times a negative is a positive. Positive times a positive is a positive, right? So every time you had a pair of values and you were multiplying, it became a positive number. So same thing with our exponents. When we have an even power, we know that we are multiplying it that even number of times. So there's plenty of pairs there where those signs will end up canceling, resulting in a positive. So keep that in mind. But when you have a quantity that's a negative raised to an odd power, so for instance, if you had negative 7 to the third power, keeping in mind that the negative 7 is in parentheses, well, think about that logically. Negative 7 times negative 7 times negative 7. That's going to be negative, okay? So I want you to think about that carefully and critically as we move through all of these order of operations problems. That way you're not tripped up at any point. Okay, perfect. So after this, notice we have M/D. So essentially what this says is we are going to multiply or divide from left to right. And what I mean by that is if division comes before multiplication and they're butted up against each other back to back, then you're going to divide before you multiply. Here's an example. What if I give you 10 divided by 2 times 6? So we have 10 divided by 2 times 6. Before this discussion, you might have multiplied the 2 and the 6 together so that you got 10 divided by 12, and then you would say, oh shoot, 10 divided by 12, well that's a fraction, right? 10 over 12, and if I reduce it, it'd be 5 over 6. Okay, I mean, it could be a fractional answer, right? I mean, who cares? It totally can be. But the issue is you're performing the operations in the incorrect order. So because division and multiplication are here butted up against each other, you're simply going to move from left to right. So you are going to say, okay, well, 10 divided by 2 is 5, and then 5 times 6 is 30. Keep that in mind as you move through performing the order of operations. Lastly, we have addition and subtraction. And same thing, don't overthink it, just simply move from left to right. Okay. My advice for you all is as you do these problems, it's helpful to read the entire expression out loud, including stating all of the operations you see. And I'm going to show you exactly what I mean here. So check this complicated problem out. It looks a little nuts, right? We have parentheses, we have braces, right? They're not curly bars, they're braces. We have a lot going on. So technically, here's what this expression says. 12 times a quantity of 2 times quantity 4 minus 7 to the second power plus 9 times the quantity 12 divided by 4 times 6. Okay, so we heard times, we heard raised to a power, we heard subtraction, addition, division, multiplication, we heard all sorts of things. So one of the first things we want to do is we want to work in the innermost set of parentheses. So innermost sets, in this case, there are 2 of parentheses. That's where we actually want to begin. So I want you to consider that we have a 4 minus 7 inside of a set of parentheses. So we have an operation here that we can actually perform. In our second set of parentheses, 12 divided by 4 times 6, we have 2 operations here that we can perform. We learn when multiplication and division were butted up against each other, you're simply going to move from left to right. Okay, no problem. So, and awesome Hannah, I'm so glad you're back. And Ciasia, hopefully it'll correct itself. So we have 4 take away 7, which will give us a -3. I'll fill in everything else in a moment. I just want you to see what I'm doing. And then notice we're going to move from left to right. 12 divided by 4, that's 3. 3 times 6, that's 18. So I want you to notice what happens here. I simplified what's inside the set of parentheses, and I'm going to bring everything else down. So far, so good. The 2 was in front of the set of parentheses. The power of 2 was on the outside of the parentheses. Then plus 9. And now, notice we have a set of braces. So we're not going to forget this. As we rewrite our expression, we want to keep track of all of the parentheses, braces, signs, coefficients, powers, all of it. We want to be very, very careful. Okay? Excellent. Next, we took care of the P in PEMDAS with reference to everything inside the set of braces. So make a note to yourself that we're trying to figure out what's going on here inside the set of braces, which is our P in PEMDAS. So we have 2 times the -3 squared. Just by saying that out loud, you should say, oh, wait a second. 2 times a negative 3 squared, that means a negative 3 squared has to come first. My exponents must be performed before multiplication. So if it helps, I can go ahead and circle this. Negative 3 squared, that's a negative 3 times a negative 3, which is a positive 9. Bring everything else down. Again, focus on everything within the braces. We have 2 times 9 plus 9 times 18. Right off the bat, I would hope you see that because we have sets of products that are separated by addition, we need to multiply first. So we have 2 times 9, which gives us 18, plus 9 times 18, which is 162. Bring your braces down, bring the 12 down, and now reevaluate. Excellent, Hannah. So, and thank you, Kayla, for that. So, yes, so now, again, focus on your braces. We have 18 plus 162. That's going to give us 180. Notice how every single time we look at evaluating this, we're saying to ourselves, braces are the P in PEMDAS. So we're still focused on what's inside. Stay inside, stay inside, stay inside until you finish evaluating everything within the set of parentheses, in this case, the set of braces. And last step, that says 12 times 180, so my final answer is 2,160. One thing I want you to notice is the shape. So as we evaluate, we essentially have this funnel shape that we're funneling towards the answer. So we're evaluating step by step, and we're being very careful to apply the order of operations. Remember, the order of operations essentially refreshes itself every time you're working within a set of parentheses. Awesome. Very nice. Let's take a look at some more examples. First, I've provided to you an obnoxious example. This has negative 17 minus negative 27 minus negative 48 plus a negative 36. Blah, gross. What I want to get across with this particular example is I really want you to focus on just cleaning up your signs. This is a mess. This is just chaos, okay? Let's clean up our signs first. So we have a negative 17. Well, that becomes positive. We have a minus negative 27. So minus a negative 27, that becomes plus 27. Then we have minus a negative 48. Well, 1, 2, 3. There's 3 negatives here, so it's going to stay negative. And then lastly, plus a negative 36. Okay. That becomes a minus. Remember, 2 negatives make a positive, 2 positives make a positive. A negative times a positive is negative, and a positive times a negative is also negative. At this point, we have addition and subtraction left, so all we're going to do is simply perform the indicated operations from left to right. 17 plus 27 minus 48 minus 36. We are going to plug it in exactly as we see, and we should have our final answer of negative 40. And it's as straightforward as that. Don't overthink this. When your last steps are addition and subtraction, just move from left to right. All right, let's take a look at number 1. Reading this out loud, you have negative 3 times the quantity 5 minus 15 raised to the second power plus 44 divided by 22 times 6. Okay, let's take a look. So, applying the order of operations, we're going to start by working within the set of parentheses. We have 5 minus 15. That is an operation, so we can certainly perform that. So 5 minus 15, that's going to give me negative 10. We rewrite everything else. Let's put a little check mark. Let's move to the next step. E for exponents. We see here we have negative 10 squared. So I'm going to circle that just to kind of be a reminder that I'm squaring that quantity, negative 10. Negative 10 times a negative 10 is a positive 100. Perfect. Let's put a check mark there. Next, you know that we have multiplication and division depending on what we see first. So notice here we have negative 3 times 100 plus. This plus sign separates the first term and the second term of this expression. So what I can do is I can say, well, negative 3 times 100 is a negative 300. And I can also say 44 divided by 22 is 2 times 6 is 12. So we bring down the plus, and we've evaluated that term. 44 divided by 22 is 2 times 6, which is 12. And that takes care of both multiplication and division. Lastly, we're going to move from left to right. So negative 300 plus 12 will give us a negative 288. And that takes care of the last two. Yes, Kayla, excellent job. Try number 2, but as you do this problem, please read it out loud so that you can hear what those operations are. If you're not in a space where you can read anything out loud, then say all of the operations in your mind. Kind of yell it out in your mind so that you know exactly what operations you have to do and in which order. Give this a shot. 60 seconds starting now. Okay, so we have lots of answers coming in. Let's reveal how to move through this problem. So again, let's rewrite PEMDAS. Why not? If it's helpful to use as a guide and kind of check it off as we go, why not? We should. So P, innermost set of parentheses, we have brackets, but then we have parentheses even deeper. Notice here within the set of parentheses, it says 16 divided by 2 squared. Well, let's think about this. If you had to decide what to do first, 16 divided by 2 squared, do you agree that the E exponents would be performed before division? You should. So 2 squared is going to give us 4. So because 2 squared gives us 4, now we can say 16 divided by 4 is 4. We have 11 minus. Now, typically, I would say, sure, bring down the parentheses. But because there is no exponent around here, and we're also saying 11 minus that quantity, we can drop those parentheses. However, do you see we have brackets here? Those cannot go away. We have not done anything with that yet. Bring the 3 down, bring the plus, bring the 18. At this point, we go back to the idea of PEMDAS, and we recognize, oh, wait a second, we have another set of parentheses. It's our bracket. So we have to take care of what's inside of this bracket first. So we're going to say 11 minus 4 gives us 7. In this case, I'm going to bring the brackets down because of the relationship with 3. Notice this says 18 plus 3 times 11 minus 4, right? 3 times 11 minus 4, which is 7. So again, bring everything down. In this case, 18 plus 3 times 7, that's a no-brainer because what has to come first? Addition or multiplication? We definitely have to multiply first. 3 times 7 is 21. That gives us 18 plus 21, which leaves us with 39. Excellent work, excellent work. I love that all of you were testing this out and trying your hand at this. There was so much participation that it's fantastic. It makes me really, really happy. And honestly, I just want you to try. It doesn't matter to me what numbers you get. I'm not going to focus and say, oh, you know, that's not correct. No, it doesn't matter to me. What matters to me is that you actually tried and gave it your best shot. I hope that this is clear in terms of how we made our way through the order of operations, and in the sense of being careful and making sure to work from the innermost parentheses outwards. Let's try one more on our own. Look at this crazy thing. So we have, and I'll read it out loud, -7 minus the absolute value of -8 minus 3 times the absolute value of -5. 60 seconds, starting now. All right, so lots of answers are coming in, and this is fantastic. This one was super tricky. 2 of you have typed into the chat the correct response. This is pretty fun. I love it. Let's take a look. So I gave you advice in the live chat, and I said, evaluate each absolute value first. Yeah, that's true. So here's what we're going to do. Notice here we have the absolute value of -8. So right away, I'm going to say that the absolute value of -8 is a +8. That takes care of that. We still have a minus in front. We still have a -7. Over here, we have the absolute value of -5 is 5. Now keep in mind there's a negative, there's a 3 in front, and it's not -3 plus 5. That's not how they're connected. Our original expression said -3 times the absolute value of -5. So we are still multiplying that -3 with the quantity or the evaluation for the absolute value of -5, which is +5. Now that I have, yes, exactly. Now that I have my absolute values taken care of, I've evaluated both of them, then it becomes a lot more clear in terms of what we have to do next. So again, let's write out PEMDAS just as a guide. We took care of that. We don't have to worry about any exponents. So let's multiply. So we have -7 minus 8 minus 3 times 15. Okay. -7 minus 8 minus 3 times 5. Did I say 3 times 15? I meant minus 3 times 5. Huh. Ooh, Patrick, that's a good point. It's kind of messy, and that's why I wanted to read it out loud first, just to say that it was a -7 minus absolute value of a -8 minus 3 times the absolute value of -5. That actually adds to that concept of make sure you're reading it out loud first completely and carefully before you move forward. Next, next we're going to take -7 minus 8 minus 15. We simply move from left to right, and -30 is the correct answer. So nicely done. I'll just move that. I'll just do that. Nicely done. These can be, they can be tricky. They can be tricky at times. It just becomes super, super, super important for you to take a step back, read it out loud first, figure out what you're hearing in your mind, and then say, okay, innermost set of parentheses, work outwards, being very careful with every step along the way. All right, let's go back to our notes and see how far we can get. Okay, so how about we do one thing? I'm going to give you all an opportunity. Kayla, yes. I'm going to give you all an opportunity to do a challenge problem. Okay, so I have a challenge problem for you all that I'd like you to try. I'll give you just a few minutes to do this. And the first 3 people to get the answer correct in the chat, I'll make a note on my chart here, will get a point towards your first test. So challenge problem is your bonus test point. Okay, first 3 people. Okay, I'm going to write out the problem, and then you will all go to town. -11, absolute value. 4 minus -6 minus 3 quantity squared, absolute value, minus 5 squared divided by 5 times 2. Have fun. Let's take a look. Negative 857 is correct. I will show you how we move through this particular problem. Yes, nicely done. Okay, first things first. Negative 6 minus 3, negative 9. Bring the power of 2 down, minus 4. You have absolute value bars here. The negative 11 is in front. If you would like, you can apply this power right now since we don't have to worry about that sign. So minus 5 squared is 25, and then we have divided by 5 times 2. Cool. Okay, let's focus on everything that's going on within these special type of parentheses. 4 minus a negative 9 squared. Okay, well, we've got to square everything or square this quantity before we do any kind of subtraction. So that gives us 4 minus negative 9 squared is a negative 9 times a negative 9, which is 81. Keep in mind, I had to bring that minus sign down. So we did get a positive 81, but you still have that minus sign you got to bring down. Absolute value bars, negative 11. Because we have minus 25 divided by 5 times 2, if you would like, we can simply move from left to right and take care of this side of the problem. So we could say negative 25 divided by 5 is a negative 5 times 2, which is negative 10. That takes care of the right-hand side. Let's continue focusing on what's inside these absolute value bars. We have 4 take away 81, which is going to give us a negative 77. So 4 take away 81 gives us that negative 77 within the set of absolute value bars. Bring down the negative 11. Bring down the minus 10. We learned from our last example, we want to evaluate the absolute value before we do any sort of multiplying with its coefficient. So the absolute value of negative 77 is positive 77. Bring down the negative 11. We put parentheses around the 77 because we're showing that these are still being multiplied together. Minus 10. Negative 11 times 77. That's going to give us negative 847. Remember, that's that trick. 7s, add them, it's 14, so it's 847. So negative 847, take away 10, and we finish by combining these two. Ta-da! Ah, dang, Major, you would have had it. You would have had it. Be super careful. Ah, oh man, so close. So close. That was awesome though. I hope you like the little Jeopardy music in the back. I figured, you know, why not? Why not? Let's have some fun with it. Okay, we are almost done. Let's get through this last piece. So next we're going to learn how to evaluate expressions containing variables. Typically, we're going to always use parentheses when making substitutions. So be super careful. We don't want to go overboard with it. Kanisha, I know. It's okay. It's okay. It happens. It happens. Hannah, that is so funny. I love that. So look at this example. 10x squared minus 3y plus 2xy. And I want to evaluate when x is equal to, I don't know, let's do negative 3. And then let's say y is equal to, I don't know, we'll do 4. Why not? I'm just coming up with numbers here. So let's say you were given this expression and you're told to evaluate when x is negative 3 and when y is 4. So essentially all that this is saying is that anywhere you have an x, you should be replacing it with a negative 3. And then anywhere you have a y, you should be replacing it with a 4. But when you do that, everyone, please be careful. Please be careful. You don't want to change the integrity of the problem. So notice here it's 10 times x squared. So when I rewrite this, this is going to become 10 times x squared, where x is a negative 3. Do you see how I used a set of parentheses? We use a set of parentheses because otherwise it would say 1, 0, negative 3 squared, and then you'd be like, well, what's happening? What am I doing? Am I squaring? It would just be so confusing and it would look very, very odd. So then we have minus 3y. So minus 3y, but y is 4. And when a coefficient and a variable are next to each other like this, as in here and as in here, that's multiplication. This is 10 times x squared minus 3 times y plus 2 times x times y. So plus 2 times x times y. Awesome. That makes me happy, Hannah. That's fantastic. So now we just go through the same process we went through, order of operations. Let's take care of this power first. Circle it. Circle it. Make sure that you're paying close attention to all of those exponents. Major, that's an excellent question. The reason we would do that is because the x quantity is being raised to the second power. And x in and of itself is -3. It goes back to that idea of there's a huge difference between -3 squared and quantity -3 squared. So we have to be super careful with how we actually substitute our values. Always remember, especially if you have a power, use your parentheses and then put the power on the outside. That's just rule of thumb. It'll be very clear to you as you practice this more and more. So we get 10 times a positive 9. We have -3 times 4. And we have plus 2 times a -3 times 4. Now, if you would like, because we have sets of products, we can take care of all the multiplication at the same time. 10 times 9, 90. Minus 3 times 4, 12. Plus 2 times -3 times 4. 2 times -3 is a -6 times 4 is a -24. Do you see how we did that? We simply move from left to right. 2 times a -3 times 4. We are not distributing. This is not distribution, okay? All we are doing is multiplying from left to right. At this point, we take 90, take away 12, take away 24, and ta-da! Rachel, Hannah, excellent job. 54 is the correct solution. Look at number 1 here. We have a -m squared plus 4 times mn, right? Or 4 times m times n. I would like you to evaluate this expression when m is equal to -8 and when n is equal to -5. When we evaluate, it is super important that we use parentheses, obviously within reason. Notice what I have here. -m squared. What's being squared? The -m or just the m? I hope that you all said just the m. So when we go ahead and rewrite this, check it out. We've got -m, we're going to fill m in, we have a power of 2, plus 4 times m times n. Let's fill in our -8s wherever we had an m, and let's fill in -5 wherever we had n. When you make your substitution, it should look exactly like this. So we have a -8 quantity raised to the second power. Let's circle it. -8 times a -8 is a positive 64, but there's a little negative in front. Let's bring it down. Let's bring it down. Exactly, Doc. Let's bring it down. So now, notice here we have 4 times a -8 times a -5. 4 times a -8 times a -5 is going to give us a positive 160. And all we have to do is move from left to right. So -64 plus 160 gives us a final answer. Yes, Hannah, perfect, of 96. Beautiful. Unfortunately, we didn't get a chance to finish this page. I'd actually like you to do it. So numbers 2 and 3, actually I'm going to show you on the screen really quickly again, so that way you have it. Number 2 and 3. For number 2, we have, let me fix this, it's a little lopsided here. For number 2, we have 5p squared q plus 9p parentheses q plus 4 quantity squared when p is -2 and q is 18. And then for number 3, we have 3c plus 4d all over f minus g when c is 6, d is -5, f is 2, and g is 10. I would like you to take these two home with you and bring them tomorrow morning so that I can check them first thing in the chat. All right? On that note, excellent work today, and I look forward to officially finishing these notes with you tomorrow. If I were you, I would print out Unit 2 because we will just move right into the next unit in tomorrow's class. Bye, everyone.